ready. Oops, I should be live. 10 more minutes, guys. I will buy my life ready. Share the screen. We still have 9 minutes to start. Let's put a timer not to confuse people. We did not start yet. Good. Better. Mm. Let's do the following game. Yeah, let's play this game. Question basically. In Zoom chat, can you please tell us your country and just a second. Come on. Up you go. And if you are using event sourcing in your current project, or if you ever used event sourcing experience from 0 to 5. If you can help me with this, it will be great to break a bit the ice. Get the chat open here. Chat. By the way, for those of you in YouTube, just know that there is a yes, recording is going to be available for sure. Yeah, experience 0, perfect. All right, it depends. leave you. All right, let's see more opinions. So if you join the Zoom, drop this in the chat. Portugal, experience is 1. Okay, I'm reading about. Okay, good. And I would like to continue this discussion with if more than 2. On what domain? This should be interesting. Let's see. The Zoom stream is very, very behind. It's 2 minutes behind. Strange. Austria, nice. Experience 1, theoretical. Excellent. Good. Okay. Good. As you join the Zoom, please answer this. Do e-commerce domain? No, Damian, I'm sorry. I'm not going to do e-commerce today. Actually, it's going to be a very, very silly application, just to prove the point. Okay, experience 0, all right? Good. See, participant list here on the side. That's good. 0 is still growing. I like that. Okay, it's a very mysterious type of architecture that we're gonna have a lot of fun today with. Completely brutal to the typical, completely wild, different. 1 minute to go. Oh, 20 more participants. So if you join, please, if you can answer these questions in the chat, it will help everyone a bit to know each other. And also very important, what is your experience level? And I count on you to help if you have more than 2 or more than 0, just to help the discussion. And yeah, Malaysia, 1 and growing. Excellent. Good. Good. Starting in a couple of minutes. Okay. A workshop 15 years ago. My God, Frank. You still remember? Okay. I think 3. I already make 2 startups from 0 with Flutter SQL PHP. Let me just check this a bit. Ask a friend here. What is, you confuse my ChatGPT. Flutter is a front-end framework. PHP is a backend language. And what will this do? How will this be an event sourcing project? Curious. More than 5. E-commerce, banking. Oh God. More than 5. Wow. Wow. Okay. Okay. Claude, do you want to teach? Take the lead. Share your screen. I'm kidding. When you're using when command, exactly how coupling changes. We'll discuss that. We'll discuss this if you want. If you want. In 1 minute. Simple queue service as event sourcing. It's a question from YouTube. Can we consider a simple queue service as event sourcing? Well, in that sentence, there is a conflict. A queue is, by definition, a communication that points to a single consumer. An event is, by definition, something that many could be interested of. Now, you can make, with queues and rabbits within exchanges, you can make a scenario of publish, subscribe. And based on that, you could, but queues, by definition, remove the messages once they are dispatched to the recipient. And event sourcing assumes that you will remember the events forever and ever to have a track of the history that has happened. So no, I'm afraid that queues, by definition, cannot be used for event sourcing. Event sourcing requires you to remember messages. The passive aggressive, we're going to talk about that. But why? Okay. And this Damian is a very good question about, but the same Damian? Apparently, yes. Interesting. We are on both on YouTube and 3 in AVS Cloud. Interesting. Mihai, what database? But anyway, yeah, just same Damian about it. Join the Zoom is always better. It's more fun here. Okay, good guys. So we have 40 people in the Zoom, and we should. Event sourcing, one of the most mysterious architecture, one of the most aggressive and very niche, I could say, but I'm anticipating. We have a kind of a menu today to walk over. Let's see how far we can get with this. And in case we remain out of ideas, we're gonna jump to some code to see some stuff. All right, inbox and outbox with broker. That's a consistency pattern there, guys. My plan is this. I'm gonna try to keep on the topic for 1 hour. After that, we're gonna have like 15 minutes, not more today, because I'm home alone, about questions that you might have. So when a question is related to the topic we're discussing, I'm gonna take it from YouTube or Zoom. And if you are on YouTube, you should be in the Zoom, which should I should start with, of course, a bit of a commercial. Commercial, which means, first of all, the commercial for the beautiful community that has grown with years. It's called European Software Crafters, and for this community, we do these events. We try to meet every month. We fail to do it, and we meet every 2 months, and we discuss about stuff. So as you can see here, event sourcing, event-based integration pitfalls. That's where we're going to take the outbox-inbox pattern, Damian, in greater details. The art of diagrams in July, we start from a shitty diagram and we try to make it clean. So this community, which is now the biggest in the world, focusing on how to write code that no one wants to have your head for. Being the community is very fun, it's only developers here, and we are already 65 in the Zoom online now. Good, so for next time, be in the Zoom. Right, the problem with YouTube is that there is like 2 or 3 minutes of delay between your chat and my voice. And yeah. It's not very synchronous communication. So be in the Zoom. All right. That being said, one more word about me. My name is Victor, 18 years of coding, Java champion, 10 years of training at an unhealthy number of companies, I could say. I've seen basically almost all domains, almost. Banking, satellites, loan approval, e-health, more banks, pharmacy, e-health, a lot of domains. Ads industry, yeah, and I have a lot of conference talks online on YouTube. You can find technically all the trainings that I do, that I keep repeating some ideas. I usually extract in a talk that I put on a conference that you can find recorded on YouTube. All right, and I have this wonderful community for which I do this. Yes, this is already live streamed on YouTube on my channel, and it will remain there recorded. Right, Egypt, very good. Good, so this is me, this is my daughter. Good, so let's kick it. We have this agenda here. I don't have much slides today. We're gonna, ciao, Victor. Nice beer, huh? Yes. Yeah, this is for the companies I've been through. So let's start with a bit of the basics first, and then we'll dive in. I see most of you said 0 or 1 experience. So let's establish some very simple things first of all. The difference between events and commands, there is some written text here we can elaborate on. Event is something that has happened in the past, right? Command is something that ought to happen in the future. It's a request, if you want, for something to happen in the future. Now, event is a fact, okay? A fact, if you want. This is a request, if you want. Now, this fact smells of, could be passed along via some message broker like Kafka, right? This, or stored in a database that we're gonna do today. Command is something that should happen in the future, which is a request that is most intuitively to think of a synchronous request coming to your application, like a REST call or a SOAP or a gRPC, synchronously coming to you. But surprise, surprise, it can also come as a message on Rabbit, for example, place order command, place order coming on Rabbit. So the commands can also come asynchronously. That makes it a bit confusing, really, in practice. But event is something that has happened. Command is something that ought to happen, that must happen in the future. Quick jump to the code. I'm going to do this round trip. I should increase a bit the font, probably. Yeah, maybe you're watching on a tablet or a TV or a mobile in the metro. So let's take an example. We're going to play a lot with this user class today. And this user class over here, you can already see here a command handler and an event handler. A command handler will take the action to confirm an email of the user. So it's going to say, I want to confirm the email of this particular user instance. I want to confirm that this user has indeed this email. This confirm email is a way to handle the action that I want to do on the user to confirm its email. This confirm email comes right now over a put. Okay, this right now comes over a put, but technically it goes into here, into my aggregate. The aggregate is technically a sort of a data structure that has a much more rich behavior. So virtually every single event sourcing system is going to make use of these things called aggregates. This is basically a thing that has in the past a trail of events that have happened about it. So for this user, there are a bunch of events that might have happened in the past. Let's have a glimpse of here. The user was first created. Then the user was activated, perhaps. And then the user email got confirmed, and the user role has assigned or revoked. These are things that have happened in the past about this particular aggregate. Right? Now, if you come from like most of us, from a world in which we store data in a relational database or a Mongo, this is probably your entity. Okay, but we call it aggregate, not to confound you, but to explain that the user itself might have children entities around it. In this simple example, I don't have, but I might as well have a private list, for example, of addresses, right, that I want to maintain, right? That could be, yeah, in your world, probably one to many. This could happen, but these addresses, they still fall under the larger concept of the aggregate of this user. One user instance has some private children, if you want. And then the whole graph of object that surrounds this user and his little friends, its private friends, is considered to be the aggregate. And we're gonna record history, basically, of this aggregate instance, okay? Damian, that's a very long question. I can't read it right now, but I will at the end. Please paste it again. Short messages, if you like, please, to get them. If you want to get them synchronously to me, not asynchronously. Good. So we have this aggregate, and this aggregate has actions that it can fulfill. Confirm email, right? Now, to start from where most of us are, normally in a confirm email, probably some of you might still be confused that if I am in an entity, let's say if in a data structure, why do I have behavior inside? Welcome to event sourcing. This confirm email, I would say that normally we could do this. I believe this would make a lot of sense to most of you. Let me simplify the code a bit to have it as clean and as possible. There we go. This confirm email. We're going to check first that the email that is of this user recorded from the past is the same user that we are confirming. Just a second, I have a little silly thing, but it's going to annoy me a lot. Is this stupid on-frame deactivation things? Good. And then the same thing here for this. I hope it's not the same problem. No, this doesn't. All right, good. Just a second to get back on where I was here. So this confirm email is a method of a data structure that basically we tell the user to confirm, right? Confirm the email. Normally, the traditional approach would be to say, you know what? I'm going to say email validated equals true. And before that, I might want to validate that the email that was indeed validated through a link in your inbox is indeed the same email that the user defined to have. Okay, so this and this should match. If they don't, throw. Good. In the traditional approach, you overwrite the value of this email validated. You say, okay, this user is now validated. It has the email validated to true. But very often, very often, let's see, where is that last modify? There you go. I'm sure you've all seen things like this. Columns in a database called last modified by, created by, and then you follow up and say, you know, not only by, but when, and so on. We call this audit columns. And this is, I've done this first time 15 years ago, just to record who touched the row last. It's a very good start in the direction of tracking who did what to the data. But the moment that some other change happens to a certain entity, you lose track of the previous last modified by. So you only record the last change of this structure. And in this structure, if this structure has a lot of fields, you will not know what happened when. Get of zero, get of zero doesn't fit, don't remember what I mean. So get last modified by last modified time is an incipient attempt from many years ago to keep track of the history a bit, to know who changed it last, so to know who to blame, right? But unfortunately, it's a bit simplistic, let's say, oversimplistic. It's easy to implement, of course. There is actually support from Spring. If you're using Spring, you can just say here in the last mod, if you had a private string last modified by, there is actually support from Spring last modified by. I should read into this. Done. And it takes it from security context, put it here. Out of scope for today. The next level of auditing and tracing what happened with a certain entity is to have a dedicated entity, which I called myself audit in several projects for a bank. And I was inserting an audit row in another table saying that I just confirmed the email by who, now, right, the timestamp, and other data, right? Sometimes you might want, we ended up here passing JSON bits just to explain the actual more metadata of that audit. What am I actually auditing? What was the actual business action that has just happened, right? What is get first? What is that? What are you talking about? So this is option number 2, to have an audit table that you insert a row every time you do a change, right? The first possible one was this. Second one was this. And then there is another option for you to explore if you are, basically, let's start over a bit. What the heck is the main purpose of event sourcing? Event sourcing is all about having an authoritative, let's put this more, okay? Having an authoritative trail of history, historical event, let's say. All the clients I know, and I know 5, 6, 7 maybe, that are using event sourcing in production, they want a single thing of it, to have a authoritative trail of historical events. Imagine the purchasing system of a government. I can't tell more, but I imagine a purchasing system of a government. Imagine Git, very good example. Git is actually an event sourced system. Imagine the purchasing system of a country that buys stuff, millions of dollars every hour, every day. You definitely want to know who approved the purchase. Exactly, it's like a changelog. It's like the change data capture, the changelog of the database. Very good, Georgios. Is very similar concept to this. All right, and Max, you are right. One of the key features, another key feature of event sourcing would be to be able to replay history to get back on track in case of failures. Exactly, to time travel back in the time. Because if you record every single event that has ever happened, the promise of event sourcing is to be able to reconstruct the state at any point in the past. All right. Corruption, Pavel. Yes, indeed, but you would be surprised in one of your neighbor countries. They are using this event sourcing system exactly for this purpose, to be able to track who, when, what they did. But by now, this, of course, failed to achieve the goal because it just records who changed last data row. This is prone to forget to, if you forget to put this line in your code, goodbye. Goodbye. Option number 3 is to have a framework that will auto-save revisions of each change of your Hibernate entity. And that framework is called Enverse. You should be reading about this. I have a client that uses this exactly for this purpose, to have what the framework is doing is going to snapshot the state of your entity in every version of its existence. Basically storing in a magical table copies of the data. The moment you change it, it's pushed in another table magically behind the scenes. Pretty good stuff to explore if you don't want to pay the high price of event sourcing. Well, I'm going to show you rockets today. I'm going to show you mind-blowing things. If you don't want that, think of Inverse. But, and also I should put here option number 4. Why not? Let's be honest. Let's explore all the possibilities. Option number 4. We call it time traveling queries. They look like this: select blah 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 as of timestamp. Some databases have this. You basically you're gonna tell, I want the data in the history back then. These two are very similar. One does it at the object relational mapper level. So basically, Hibernate is going to automatically insert a new row in another table for you with this extension inverse. And this one is just in the database level. So if you are not using Hibernate, that's your only chance right now to see the data in the past, if you have tracking of history enabled. Now, event sourcing goes a step beyond that and says, you know what? All the data that we keep in the users table, I can nuke, I can destroy, because all the changes happening to an aggregate are going to happen only by means of an event. So we're going to record deliberately every single possible change that can happen to that aggregate, basically. But you know what we gain? We gain semantics. We know exactly what is the purpose behind the change. It's not just that we're capturing the data in that row or in that object from the previous version. Is that we are explaining what we are going for. It's just like if you compare this with event sourcing, you understand I'm going to persist events, right? What the heck? Let's go on one more second here. So technically, this is going to just show you, imagine 3 or 4 is just like looking in your Git history with no Git commit messages. Just the diffs. But there is no meaning behind this, right? No, data is cheap, Adrian. And the domains that I know that they use event sourcing, most of them, not all, most of them, they are not dying under a terrible load. I mean, how many purchases does that government do, right? How many loans get approved, for example? How many purchases of pharmaceutical B2B purchases happen per day, right? 20, 100. So the amount of the data volume in an event source system is, I would say, typically not humongous, okay? Exactly, auditable. Exactly, this is the annotation. Exactly this, Hibernate inverse. You put auditable on a column, and your job is done. Your job is done. This, boom, done. And it's a good alternative. It's a good alternative if you don't need the semantics behind the scenes, right? You get the versions of everything that has happened, but you cannot really replay history. You cannot run Java code or your code to rerun stuff. It's just data snapshots. The intent behind those changes is lost. It's just like looking at the Git history with no commit messages. With event sourcing, the perception changes a bit. Just a second to restore here the original code. This is what we do normally, right? We nuke the data, and when we insert this to the data, when we update the entry, inverse would insert previous version in another table, and then Oracle or Postgres will allow you later to time travel to see the data previously. It's a bit risky to rely, and you can't just say to rely on this time traveling for legal purposes, right? So that's why the confirm email action, command handler to speak correctly, is going to return an event or more, usually one, an event of more, but it will not change anything. So in event sourcing, when you process a command, you will return back, and this is brutal for brain. When you need to change something, you don't change something. You don't even have setters on this entity. You only have getters. So the only way to change it at all is to return an event from this command handler to who? What happens afterwards? This event that you returned is going to be processed and applied to the data. Can this scale horizontally? Well, I would just tell that the volume and the load are typically small for such systems. Typically. If you want to scale horizontally in general, you will have to start considering sacrificing consistency. So you're going to have to think, okay, I'm going to push to a Kafka and then consume it from multiple places, but you need to allow this window of inconsistency in that moment. And event source systems don't usually afford this window of inconsistency. That's why EventStoreDB, Axon, or custom implementation are going to prefer to do these things transactionally. Your best chance to scale horizontally still, Damian, is to find the partitioning key, for example, geography. And you could store the lawsuits, another example from my clients, lawsuits from Europe in this data center, lawsuits from the States in that data center. And then you have each with their own event trail, basically, right? Or by tenant ID, if you want. Yeah, partitioning on a higher domain business point of view, basically, right? But then you apply. What happens in the apply? Let's see. The event goes here. Please notice this, but I'm not going to talk yet about this. We're gonna see this in a second. But what happens in here? Let me put everything on the screen so they can see. Does it fit? Oh, it fits. Good. There. So when you have an event produced from a command handler, that event, first of all, I'm going to load the user from the database. Now, why? You could say, you don't have it already loaded? Well, I explained that these events that we manipulate every day as the source of truth are going to be inserted in a long trail of events for every single aggregate ID. So a user ID 13 is going to have a trail of events. Now, these events over here are going to be saved in a database. In my case, in the same SQL. But then if I ever want to destroy the actual user table, I can rebuild history by replaying all this through this processor, okay? So there is this ability of replaying. Let's hope that the demo gods are going to allow us to see all these features at the end. So fetch the user from the entity. Okay. This is a protection. You don't need to understand this right now. It's a protection against mischievous changes of entities. Command handlers should not change state. That's why I'm making sure that they do indeed not change state. Then the user, if it's not found in the database, it means it's a create command. It's a create event that user created. So you have to create one new one. I'm going to make sure to record the author, probably from a security context, from a GVT token or something like that, and then save the event, period. This in here is saved in an SQL. What I'm showing you in front of you here is a ACID event sourcing, like the default and like we should do probably always. I'm inserting the event, and then I take the event and I apply it to the user. Ah, okay. And the apply is the only action, the only method in the aggregate which is allowed to change the state. So let's see what happens in here. If it's a user confirmed event, then the email validated is set to true. So the change that you wanted to do here, you don't do here, you return it to an event, the event gets safely stored in this event table, and then that event gets applied back to you here. Yeah, okay. So the apply will take the email confirmed event and it will set the state. And the only place where you are allowed to change the state of your entity is in the apply method. Why? Because you remember all the events that ever happened for this aggregate are stored in database. If you ever want to rebuild all the changes that ever happened, you just have to get all these through here. And your user is going to reconstruct the state exactly because that's the only way to ever change the state of this user. So you're going to tie yourself in handcuffs, in fluffy or pinky handcuffs, forcing yourself never to change the state of this entity unless through this method. And then if you store all the events that have ever been passed to this method, you can technically rebuild history at any point in time. Let's see what kind of events can happen. User created is always, the creation event is always, wow. Outside in Romania on 10 April, it's snowing. Not sure if you can see. Snowing. Dang. Strange word. So, user created. Creation is always a tricky event because there is no aggregate to apply the state to. Okay? You're going to discover this if you play this. You're going to have some discussions about the creation event, but technically it fills the state of your user with that creation event. So most of the state in practice will be here in the creation event. Not all, most. Then user updated. Again, probably you can change name and department, but you cannot change the ID. You cannot change the email validated. It's the same way as before. You can change department, but you never reset that flag, for example. User email updated, you're going to change the email and set the validated to false because you have to validate the new email again. And I'm not showing you, isn't this function going to explode with the number of events? Yes, indeed, Max. And that's why, let me bring the friend on the screen. That's why, a second. We all have a friend nowadays. Some call it a dog. Where are you? Come on. Good dog. Good dog. That's why in Axon, for example, in Axon, you have these event sourcing. This is just more framework engineering. You can, based on some reflection kung fu, be able to untangle all this. Basically, you are worried about how big this method is going to grow, right? This method can indeed, it's already pretty large. It's already 30 lines for just a silly application. So you can untangle this by using some reflection magic. I'm sure that you can, right? If you are here at this time of the day, probably you are passionate about it. So I will leave it to the joy to do this. I've seen another approach in which the user updated event itself had an apply method here. People weren't very convinced about this is a good idea, but apply to user. The starting assumption was that once you have events spread in many classes, stupid classes, why not having logic inside of them? That leads to some discussions about the visibility of the setters and the mutations of the users. Might lose some of the benefits. Not really. Questions. What happens if, guys, coding is, I believe, pretty obvious. There are many online tutorials about this. So questions is more I'm not interesting about. Let me make sure I watch the YouTube also. Just a second. Ouch. Let's start with Zoom. What happens if we need to change the behavior and that breaks the chain of events? Versioning to handle both flows before and after the change. So technically you change the way that events are, but I did not mention yet anything about the event chaining. You are right, there is this concept of event chaining, but not yet on the screen. It's basically events can trigger more events. We call them reactors. Basically here, reacting to the event that the user was created, I will auto-fire another event after I am sending an email through to the inbox of the user. So I got the email out. Do you know the email asking for the confirmation of the email address? Basically, yeah, you received the email. Please confirm your email address by clicking this link, right? And immediately after I'm able to send this event, I will fire another event that will tell that the email was sent, right? And someone could listen to this one. So Tiago puts a very interesting problem. What happens if you change? This is basically an event chaining. Reacting to one event, you fire another event. What happens if you change this chaining? So there was a command at the beginning, command going in. There was a first event going out. In a reaction to this, we have this call going outside, which leads to another event. What happens if I want to engineer something here? With event versioning, I can only point you to the God about this. There is a famous book that you definitely, if you asked, you should definitely read it. It's called Event Versioning, Greg Young. It's a book that was never finished. That's fun. It's 80-something% last time I checked. Status. Let's see here, I think. Yep, this. It used to be free, not anymore, but it's almost done. It's 90% completed since 2017. Greg Young being one of the main promoters of CQRS and event sourcing. And this is a very wonderful book that you need to read if you ask about versioning. You will learn about upcasting, downcasting, and also Axon framework documentation is a very good place to start to understand the different types of event upgrading. Technically, what you want to do there, Tiago, is there are two main. Okay, just a second here. There are two main approaches to what you're asking there. One approach is to rewrite the event trail. This is the most brutal one. You take the event trail, hundreds, thousands, one event, and you basically process each of them. Is like this is the most close equivalent to a database schema migration. You technically transform each event in a matching new event, but this matching new event could actually be a different shape, could be 2 events. You are rewriting, right? Ugly, painful, very painful, but it's the most brutal solution. The other more lightweight solution is to leave the events in where they are stored, and when you read them from the store, you process them and you transform them to something else. 1 or maybe 2 can get out of a single event in the trail. This will work until a point. At some point, you might, after several years, need to rewrite the history carefully, not to lose any, basically creating a new event trail with the new versions. It's a painful discussion there, Diego. All right, so continuing. I was saying that, the book, mind the book, it's all recorded, watch the recording. Email confirmed, email validated. Now, there is a very, 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 very painful and interesting discussion in practice about when do we validate stuff. I have my agenda here. I want to walk it through, right? But let's see the rest. We discussed event versus commands, yes. We discussed that command handlers would only produce events, and exactly how you output these events, it also depends. This is the solution here, the most simple solution you can imagine. Another solution would be to say, register event, and use some sort of magic to publish this event. Let's try to, you know what I'm gonna do? I'm gonna actually make it work in a bit. This is event to publish. You can just return it out of the command handler. This has the advantage that since you return the event, the command cannot return anything else, and the commands should not return anything else. Then you can use some magic and say register event. You need to read here about something called abstract aggregate event root, abstract aggregate root from Spring. Okay. Or third option, like Axon does it, to use something like this. Basically a static method that magically just publishes that event outside. Right? But the most clean to understand first is just you returning the events to process next. State machine, yes, indeed, there is a sort of similarity. You can imagine all of these events as arrows in a state machine. That's a good comparison. So technically, you record every transition as an event that has transitioned to. The match is not perfect though, Julia, because in a command in a state machine, there is an action that results in a transition. There's a verb in there, right? Activate. Here is user activated or created. It's a past tense. It's a fact. But indeed, during as a consequence to this fact, the state of this user changes to another state, basically. Very good match. You see this also if you implement your own custom state machine. Okay. I lose my zoom. And there were questions in YouTube also. Wait. Blockchain. What? Debezium is change data capture. Debezium. Business use case domains. Yes. Public purchases. Loan approvals. Lawsuits management. What else do I have? What is e-commerce for some identity providers like users? Okay, someone asked me YouTube to provide some actual business systems. With domain-driven design concepts from, it is an extremely good match because this aggregate design thing comes from domain-driven world, which talks about many years ago in the blue book in the domain-driven design tackling complexity in the heart of software. Eric Evans talked about the aggregate and domain event, and these events that we look at here are basically domain events that your aggregate. But the trick is that the domain events here are used to rebuild to change my state. How domain events were used in domain-driven design were to let other aggregates know about some of my internal changes. Interesting for others. But here we use these domain events as a source of truth, basically. It's a good modeling approach to start thinking of domain events. Also a matching technique, a very good technique to play with this is event storming. And you should definitely listen to another talk that was for my community. Let's see, where is it? Miron Victor event sourcing. Let's see this. So go live on YouTube. This. Yeah, basically, I had a speaker telling us how a good match are these two, event sourcing and event storming. Storming, right? Brainstorming. We call it the post-it wars. We throw post-its on a wall to identify the main business events that our business guys want to talk about. Very good technique. More questions here. Name governance. What about when you change the way you handle an event? Yeah, interesting. Versioning, the same point I'm gonna do that book. What if between one processing and the replay, the data structure SQL table entities changed? Well, technically, I can destroy the table users. I can technically destroy the table users and be able to reconstruct it completely from the event trail. So maybe I'm missing the question there. All that matters is the table of events. That's it. See if I have it here. I don't remember if I connected my IntelliJ already to the database. No, apparently. But I have an event entity that you should look at and think. Where's my event? Event. Start event. There. This. And normally, this event over here will represent basically all the changes that have happened. And what the heck? Let's go slowly to the demo bit because it's getting a bit late. We can think of stuff over there. Let's make a bit of order before the user. So what I said is that command processors return events in different implementation options. Then events are applied to change the state. The only way to change the state is through these events that also get stored somewhere. And I was about to tell you about the validation, which is a good practice to start to happen as much as they can in the command handler. Now, if you write the validation in the event handler here, it's too late. It's too late. It's pretty not even correct to store the fact that user has confirmed the email if the email inside does not match the internal correct email of the user. So it's actually, in this particular case, not correct to put it here. You should put this in the command handler, checking right here at the beginning if the command makes sense or not, if all the required fields are in place or not. Another example in this sense, if you, for example, here, only here, require the department ID to be not null, it's too late. It's not correct to have recorded an event of the user created unless you've checked all the payload, the data that you could. So when you actually create that, let me get to the create flow. We call it user REST API, and we have here the create user. Notice that here I am basically constructing this event in here. This is a mistake, really. This is a mistake. I apologize. This should be an, let's say, created event, right? And then you see that I'm publishing here more events that assign roles to this user. So how would this look like? Let's write here a list of Mondog event, no, event abstract event, or what the heck? This is an user role assigned event. Good. And this is, let's say, yes, thank you. Good. And then I will have to process everything, right? Apply. And just a second, one event, good. And I'm gonna just say to this user created, and then for all the, yeah, I should say like role events, dot for each apply, for each, good boy. Now this here technically should be the command handler, isn't it? This is a method. What does it produce? It produces these two things, but I would love to have them as a list. Let's say I have to collect two lists to make it a mutable list, not unmodifiable, but just two lists. That's, come on, dog. One list, a list of events, and then to this list I will have to add. There we go. A bit of a mess here, but list.add of a created event. That's actually a good suggestion, dog. Just add it on the first position. But what am I doing wrong? The type. User event. Good. And then I can just iterate through all of them, saying apply all. There you go. And this is events. And now this thing over here is the command handler. Still doesn't really work. 1 second. Here, this is like create. And the method create should probably be in the user itself. Let's see, can I make this static, please? Yes. Can I make this public, please? Yes. Can I move this, please, to the users? User, perfect. Great. So in React to a command to create the user, what do? I respond with a list of events like you see here, okay? Which is then blindly applied by the processor. Now it's much more better because the logic exactly. And I'm trying to say that if the department and ID must be there, it is too late to validate this here. Too late. You always prefer to validate payload constraints here in the command processor. I have the luck here to be in a synchronous flow. The synchronous flow is a REST API, so this is going to fire an exception to my client saying, whoops, you missed that. All right. Yes. Let's start the demo, but could the data become invalid between command handler and event handler? Well, no, because I am changing both synchronously. And to prevent this concurrent changes, you can just go to the user and add to the user a version, which is optimistic locking. So the moment you change both, you insert the event and you change the user, if someone else changes the same user at the same time, you're going to get an exception, optimistic locking, please try again. Okay. Event handlers should only apply changes to update the aggregate state, not validations. Exactly, very good, Adam. Exactly. It's too late to do this here. However, there will be some validations that, or business rules you might want to apply here. But normally, shouldn't be in the aggregate, should be in a policy. Should be somewhere else. If an event triggers another event. So basically, the event application should not normally fail. Because philosophically speaking, you cannot refuse an event. An event is something that has happened. You cannot say no to history, although some people try to. You can't say, well, thank you, but that event can't be processed. Who are you to reject history? So if something could fail, that's a policy, that's a reactor, that's a processing of an event resulting in another event. This can fail, right? And then what happens if this fails is another discussion. Maybe you need some human intervention, maybe you need to retry, etc. And we fall into distributed systems pitfalls there, right? Source events from the domain. Yes, all the events here speak in the name of domain. That being said, I do want to show you the demo. Although you could say it's naive and superficial, but I don't care. It proves the point. Let's see. Localhost 880. So, first of all, see all the users. One user to rule them all, John Doe. Good, which is a user for the application one. Good. Let's look back in the history and let's see, first of all the events there. Now, in this particular simplistic example, I am storing all the events next to the other, but somewhat surprising, I record in each event also the snapshot of the user at that moment in time. It's a questionable approach. If the data that you're managing is very, very large, imagine the data of a lawsuit, it can be hundreds, if not thousands of attributes. You can't just snapshot everything every time, right? But for a simplistic example, this is the state at that moment in time. So originally, John Doe had this email, was a department ID. After this created, the confirmation email was sent. Okay, nothing changed here yet. Next event, user was assigned some roles. For example, he was originally admin at the application one. Okay, who did that? Who granted this guy admin on application one? Victor. Okay, when this, okay, that public purchase, right? And then user role assigned. Another application is assigned. This is a snapshot. I'm looking in the wrong place. Just a second. Here. The what role was actually added? Admin for application one, and here app1 user. Good. Scroll. User email confirmed. Okay, so afterwards the user clicked. All this thing is simulated by a startup bean that just calls these things. Basically confirm the email, withdrawing a role, getting the user, putting whatever. So you see that here the user just confirmed their email. Okay, the snapshot is now active. True. It wasn't active before. I hope active null, which is disgusting. Why is it null? Bad idea. The user shouldn't be the Boolean. It's confusing. What is this? Quantum physics? Boolean, or I could say Boolean, but false by default, of course. And validated is false by default. Thank you very much. All right. Then here, next thing, user got revoked a role. Basically, the role app admin got deleted, and in the snapshot, it's only admin. It's only user for application one. Can I delete? To delete events, they want to rewrite history. Wait. Can I delete, or there is a way to delete events if I have a snapshot and the state of aggregate is an inconsistent state? Ooh. Well, the only purpose of snapshot is exactly performance. In practice, you can always rerun all the events for this aggregate ID and see, okay, for this user ID one, you can basically revisit all the events and rebuild the current state always. But if there are many events for a certain aggregate ID, okay, that can be overwhelming. For example, in a lawsuit or in a loan approval flow, there can be hundreds maybe of updates. Each time you're going to have more events recorded. It can be overwhelming to store everything in terms of memory, in terms of disk space, basically, right? But these snapshots are just for performance, okay? So normally other like Axon, EventStoreDB, they're going to store these things every now and then, not continuously like I do here. It's like Git does, for example. So the user was revoked the role. After that, user logged in. So I know exactly the timestamp that the user has logged in. Okay, what else? User deactivated. Ouch. The user got deactivated, so the snapshot says active false. Okay. So this is just I'm visiting the event. Let's see something fun next. Can I see what was the state of my users last night at 10:15 in the night? I just rebuild, basically, no, technically, you don't really need to do this click if you want just to see in my particular architecture, you don't need to do this if you just want to see the state last night at this point. You can just look at the event that happened before that timestamp. You can just see all the events, take the event last one before the timestamp, and you got the state. But what you can do very nice is to attempt, so you have events, many events, event, and then you are interested to see, you had a bug, basically, to put it bluntly, you had the bug, okay, this is a bug, trying to draw, you had the bug in the code that caused the system to fail last night at 10 a.m., at 2 a.m. in the middle of the night. With this event sourcing, you know exactly the state at that point in time. But more than that, I mean, you could say, okay, inverse or change data capture could do the same. I know, but what you can do very nice is to say, fix the bug, and then replay history, rebuild history until that moment in time, and then run an application with the fixed bug, exactly, basically, rerun the code with the fix on the state like it was last night. You can do this with event sourcing. You can rebuild history until a point. This is what happens when you say rebuild. Look, see all the users. Let's do this first. John Doe. Go to localhost. localhost. Rebuild time travel to event 5. Let's see what changes. This was the old state, correct? Let's access again all the users to see. This was the old state. Now I turned the history back, and the state in my entity, in my table, is this now. He's user. He's admin. He's admin because back then it was admin. User logged in events will significantly increase. Guys in the YouTube, you should be in the Zoom. It's insane here. The people are answering themselves. Thank you very much. User logged in events will significantly increase your event count. Thank you, Adam, which might not be the best thing to do. Correct. Indeed. Another stream that you can manage independently. I like that approach. And Sam, you can play. Let's wait 10 more minutes and we'll talk, Sam, about use cases. Any simple question that I can take? Moving fields. Yeah, we discussed that a bit. Good. So let's see what else do we do. Every time you have an event sourcing system, you need to have somehow, because events are just, imagine a Kafka topic. Events are just describing the changes. But very often, always, you have to present to users the state of the current system. In my particular case here, I already have the users table. I already have the users table, which keeps inside all the, the current data. But I might want to project the exact same trail of events for different purposes. So in other words, these events are basically history facts. They are applied on my user aggregate, and the contents of the users table reflects the application of all the events until today. But I might want to project this information in a different way to produce a different perception about this trail of events. Perhaps I'm interested only to see the application, this last login time. Last login time is recorded here. So there is this projection that listens to the user logged in events and which updates the map in memory. This is a read projection which is not persisted in an SQL, which is kept in memory. In this case, really in my heap, or it could be in a Redis, right? This is just one side of the data. In other words, if I look at the user, you don't see here last login per application. Right? The events record that information, but in my entity, I chose not to store these things. Like you said, these events, maybe they are already persisted, but then based on that, I can create another projection, this map. So if you go here and you look, where is it? Read projection, users able to log in. This is one, but what we want to see here, user login here. No user has logged in yet because I rewrote history. I turned back time until midnight. I'm curious. I think the user did log in the original flow. No? I might have a bug. Let's see. This user logged in. I'm not going to debug it here. It's too late for me to debug. But you get the point. I'm listening to these events and I'm storing in this map what I'm interested of. This is CQRS. This is the query part of the story. A user that can log in is just going to track the users, just track these events, user activated, user deactivated, email confirmed, email update, and keep, based on this, build the list of users that are allowed to log in. This is transient, yes? This is transient. This is going to just blow up if I take the application down. But when the application starts back on, I'm going to revisit all the events in the history to see and rebuild my state. This is a proof of concept. If you really pull the plug and rerun the application, this won't really do much. That's a bit of a summary here. So, event command, event is a fact in history, command is a request for something to happen, sync or async. The main change of perception in event sourcing is that you are not allowed to change data anymore, but any command handler is going to have to return some events or publish some events, which are going to be applied later to cause the actual changes to data. And like we discussed, ideally, the command handler should reject invalid requests. And then when events are applied, nothing should blow anymore, ideally. We also mentioned about the idea of policy or reactor policy, which is basically events triggering more events, right? Plus minus external calls. That's always a problem when you hit the network. Network might be down, stuff might go wrong. So that's a distributed system problem, not for today. For next time, event-driven pitfalls, right? What if your events table grows too much? Buy more disk. Disk is cheap. Yay, next. After a significant evolution of the application during the years, do you end up with hyper-complex aggregation functions that are the combination of all historical logic changes? At some point, you should kill V1. Exactly, Hendrik. Exactly for the reason of avoiding criminal event upcasters. Upcasters means transforming to the new version. Exactly for this purpose, at some point after version 7, you would prefer probably to rebuild the events after following the current perception of the business flow. We're gonna start questions, guys. So gather your thoughts, and very soon. Commands can arrive sync async. Events can be applied in the same transaction or in a separate transaction. Stick to this for default, because event source systems are usually for auditing purposes, for legal purposes, or also time traveling. And it's also something fun that you can do with event sourcing is to change the code in a strange way and rerun the trail of facts in the history to see what would the current state be if this logic would have been changed 1 year ago. We call this what if analysis. Business is going to love it. What if analysis. You can see the current amounts of money, for example, if you apply a different commission, replaying history, very fun. Snapshots can be in the same event stream like I do, a bit simplistic, different event stream in a separate database, done every now and then, and that's in itself a concern when you choose the event sourcing framework, or if you build your own, it's a key concern. Validation should be in the command handler as much as we can. In the event processor, not quite discussed. Good. Casting and casting. Let's see. Can we think about creating snapshots each 1,000? Yeah, that's a good start. But before we start implementing complex things, you would need to make an estimate of the volumetry. How brutal, how much would you have to pay in Amazon terms if you had to if you stored every single event? Is it too much to store? If you basically put in every event the snapshot inside, would you have to pay your life for this, or is it decent? Right? With money and performance, we don't guess, we calculate. Test scenarios. Well, like you know me, I would definitely love to hear that you've been integration testing your stuff, that the whole thing acts as intended. So nothing changes in testing initially. I would say test the black box of your system. If in this system you use event sourcing inside, I don't care. If I play the same inputs, I should get the same output with or without this inside. It's an implementation design decision for a single system. That's a very important thing to note. Event sourcing is an architecture for one single system. Don't confound this with event streaming or event-based integration. This bubble, managing the lawsuits or managing the loan approvals, decided to use events as their source of truth. Whether this is a monolith storing in an SQL, or it's a cluster of microservices storing in a Kafka, it's a design decision, but technically this bubble, this bounded context, decided to event store their reality, basically. But besides the tests for the integration, I would also have to add here time traveling tests. And also very important, appcaster test. What is this all about? Can my current app read V1, V2, V3, V4, V5, V7 of the past events? Actually, you have to have a unit test for this. Because one of the benefits of event sourcing is to be able to time travel. Can I nuke the state and rebuild history? Or would I have bugs when trying to apply old events? You need to add these kind of tests. Also, I would think of this. This is, and it will be, of course, completed with unit tests. But unit tests in event sourcing are going to targeting one aggregate. You're just going to put an aggregate live, call a command handler, see the event. That's kind of, because in the command handler, there will be the most logic, business rules, if statements will be there, right? You're going to test policies alone, apart, which in reaction to an event, call some stuff or put some ifs and then fire more events. This can be tested in isolation if they are complex. But we always start with this. Changing the commission amount to changing the commission amount and replay the event. Exactly. Yeah, but events will just capture what has happened. If you change the logic and you apply a different commission, that will be in the Java code, right? You can then replay all the money transfers events, for example, and see how much more money you would have gained by now over the last year of events. So events record facts as granular and as early you can. Very important. Record these events as early as you can. But there is a trade-off here. The more early you record them, the more invalid data you will take. The later you record, the less snapshot of the history. In other words, to blow your mind completely, it might be interesting in some cases to validate the email that is the same, not in the command handler. It could be interesting to validate this in the actual event handler. But in that case, if you do not validate the email to be the same here, what you need to fire is not user email confirmed, but user email confirmation attempted. You see the difference? You record the attempt. Maybe you want to do some analysis from a security standpoint. How many failed attempts to validate the email address were? With recording this, you still have this information. So it's a fine line. The more you want to record, the earlier you're going to record the event, the less errors you want to have when applying, or the simpler the code you want, the more validation you're going to do in the commands in the initial side. Design decisions. It depends, my favorite line. What do you test during integration test? Do you receive an event? From outside of the bubble, there will be commands coming in. There will be queries asking for data. Commands could come with REST synchronously, or could come over Rabbit asynchronously. Queries are usually GET requests over REST. And there could also be some trail of events published to some Kafka. All these arrows you need to check. So if I have these commands, if I query, if I get the right thing, and where the right events published outside, mind that this E here is an integration event. It's a different kind of beast than the internal event that event sourcing uses to reconstruct history. There are different types of events. Don't confound them. A common mistake would be to publish your internal events. Don't. What do you do when you find that aggregate boundary is wrong implemented? Shit. Brother. Brother. Yeah. Well, that's why I would recommend. What should I recommend you? Patience. If you split the aggregate in two, you need to split the trail of events in two. Welcome to event schema migration. You need to build up from bottom up all the events again. It's much more painful than a database table. But database tables split is also painful, right? To have a table and turn it into two tables, it's also annoying. But with events boundary, it's even more annoying, I promise you that. Can you hack your way? You could say I have this long trail of events, but then no. Events should represent stuff around an aggregate. Or just brainstorming here. You could think that this old trail of events is an external source of event, but it's a mess. And you map them to other new events internally. So you consider that to be some ancient history has happened, and you just have a message listener to those events, okay? And you translate those external events just like were commands into your internal new events. Just brainstorming. Strange, not sure. What do you do when you find that aggregate boundary? I guess you change your job. Will this pattern break Yagni? As this pattern supports the future requirements mostly. It doesn't really, and you can't break Yagni. You could just not care about Yagni and overcomplicate it. Basically, you're asking, isn't this too complicated, Victor? Yes, it is. That's why I would recommend you use these patterns only if you have mandatory legal purpose-wise audit trail. If you want to revisit every single step and have the semantics of what has happened, who, when, what, everything recorded, this is for you. If you just want to have past history versioning-wise, Nverse or data capture could do the job. But you can't really go to the court with your transaction logins in the database and saying, look, this is my trail of nice JSON events that explains who, what, and what they did. It's much more easy to reason. And it captures the semantics of the action, like I said. More. Let's make a new. At some point, a single event can affect two core business contexts. Yes, but then that event, exactly, is an external event. It's a different event species than the event we record internally. And you have your Kafka listener set up here nicely. You listen to that event, and you turn that into an event that concerns your own ping in aggregate. Hardest. Yeah. One thing is clear. These patterns come with a very high cost of entry. Okay. As a matter of fact, many of my clients using Axon are having not doubts, but hard times. Some of them have started using event sourcing without having the need, really. It was just cool and yay. It was an event-driven architecture. They went to an event, a conference, they drove home, and then they made their architecture. I've read actually doing the next version dynamic consistency boundary because it is in event sourcing never said you should use aggregate. No, it didn't. It's just very natural to map event storming to an aggregate boundary. Only consistent stream of events. I need to read the article about this. Interesting. If you have an article nearby, paste it to a representative article. Interesting. Indeed, aggregate is not must have. It's just a very, very, very common way to do these things. And there was this, I think, Chris Richardson, I think, Spring event sourcing. I think this guy made his own. Yeah, this one. Somewhere here, there's a very scary snapshot of code. It looks like what we drew today.
Apply method or process method.
There. You see how the command to this is a command? Not entirely sure. This is a query for sure. Command. Available credit returns the money. Subtracting. Not really correct here. What happens in here? Wait. The clear is that when we process a command, you return a list of events. We see this. Okay? When you create such an event, this event is going to be there, applied to the state. That's not entirely sure what this is. Oh, this is a private method. Used from these guys, not public, you see? It's a package level, whatever. So you should not look at this. It's just the internal kitchen. Right? It is a query. This is a command processor. returning a list of events, command processor, and then applying the events there. Thank you, Adam. What is this? Adam. He's dead. Long live the aggregate. Fun. Excellent. One single like. Sad. Like this article. It's sad. Guys, I think I'm kind of done, and my environment here is cracking, falling, destroying. I don't know what happens. Ooh. My video just crashed. Am I still on Zoom? I have a CPU problem here. This is me again. Okay, good. Don't ever do this. Don't ever look at people from top down. Not good. Be here. All right, guys. So that's enough for a day. More than enough. I would really invite you to check out this repository, play a bit with it. Yeah, just to understand why you don't want, why you might want event sourcing. Good. So this has had nothing to do yet with distributed systems. Be sure to be here next time when we're going to talk about Kafka. So the next topic would be I switched from REST to using Kafka. What can possibly go wrong? That's the topic for next time. We're going to have fun. Good. Thanking you all for your contribution here. A lovely discussion in the chat. GitHub. Yes, GitHub. It was recorded, but I'm going to put it again in the chat. Just a second. Paste. No, not this one. All right, guys. If there are any leftover questions, I'm going to look one more time in YouTube. Hopefully, they got the time there because of the lag to put their questions. Let's see if there is any question. Where is my YouTube stream? A second. Question. Good. I think we're done. Julia, that's a wonderful. No, I don't have a moderator yet. Are you up for the job? No, I will not. It's all recorded. It's a wonderful idea, but never thought of this. Maybe we can do a more organized way this last time. There are like, not Slido, there are some tools to use to have a orchestration of the questions. Yeah. If you want to help me with this, drop me a link about such a tool and maybe we can use one. Like, yeah. So until next time, goodbye, guys. Have to babysit now. Have a great evening, everyone, and a great evening. Very soon, coming up soon. Goodbye. Does it work? Come on, Mac. No. There you go. Thank you. Have a nice evening.